Hello, this is Nease, and this is GRC 605, Unit 4 presentation for Business Research Methodology and Quantitative Statistics. The presentation is titled Conducting a Correlational Analysis. The goal of this assignment was to apply concepts from Unit 4's reading as well as auditory lectures. This presentation will demonstrate my ability to conduct a correlational analysis and to present my findings both in visual as well as auditory format. The GRC 605 dataset was imported into a tool called PSPP. I used the desktop version to calculate the following correlations. On the left-hand side of the slide, they're listed in order from 1 to 10, and out of these 10, I found 6 positive correlations. The agenda of my presentation today will be to review these 6 respective positive correlations. I'm also going to discuss the strength of the correlations and what I've found. We're going to talk about the main takeaways from each of them as well as in the aggregate, and then we will conclude with questions. The correlation between income and savings was the second hypothesis that we tested, and we found a significant result. The null hypothesis in this case was that there was no correlation between income and savings, and the alternative hypothesis suggested that there was. Our correlation coefficient and its p-value were all calculated using PSPP, and that is for all of the hypotheses. We used the same tool, and we assumed that the p-value, which helps determine the significance of the result, was less than 5%. What we noticed here was that a significant correlation emerged in that the Pearson's correlation coefficient indicated a very strong positive correlation. So this test rejected the null hypothesis and concluded that there was a correlation between income and savings. This is the example of the income versus savings PSPP output, and you can see here very clearly that there is a positive upwards correlation between the income and the savings of individuals. Not a surprising finding that the more you earn, for most people, the more they save. Clearly we have some outliers here as well, but this is, I think, a fairly predictable finding with a p-value here that suggests it's highly unlikely that this is a coincidental correlation. The third hypothesis test was the correlation between income and stocks. The null hypothesis here suggested that there was no correlation, whereas the alternative suggested that there was. What we can see by examining the Pearson's R as well as the p-value is that there was a correlation, however, it is weak. And we will see this on the next slide where we can look at the scatter plot. The Pearson's R here was 0.19 and the p-value was 0.018. The test rejected the null hypothesis, included that there was a correlation, but as you'll see on the next slide, the correlation between income and stocks was relatively weak. As noted in the previous slide, you can see here that there is not a strong correlation between income and stocks, perhaps a little positive upward slope here. And if you look at Pearson's R, it's also quite small, although the p-value is still significant. So we are going to consider this a correlation, but it is a weak one. This was the fourth hypothesis test that we conducted, and it was the correlation between income and wallet. The following correlation test was conducted. The null hypothesis was assumed that there was no correlation between income and wallet, and the alternative was that there was a correlation. This one actually surprised me, and I actually went back to look at the data because the correlation emerged so perfectly with a 0% chance of the correlation being coincidental. So you'll see this in the graphs on the next slide. Clearly this test rejected the null hypothesis and concluded that there was a correlation, although I wouldn't mind diving into this data a little more because the results just seem to be too perfect. As I noted in the previous slide, as you can see here, it's a near perfect positive correlation, and almost so that it seems the data might be not particularly real. It's so good here. So anyway, it is what it is. So I'm going to say that this is a perfect positive correlation. You can see here Pearson's R is 0. There's 0 chance that the p-value showing us that there's no coincidence in this correlation. So we'll leave it at this. Income versus wallet. People who make more money have more money in their wallet. I don't know about this one, but the data is telling us that this is the case, so we'll leave it at that. This was the 8th hypothesis test that we conducted. The null hypothesis was that there was no correlation between people's savings and the stocks they own, and the alternative was that there is a correlation between savings and stocks. I think it's kind of common sense that there probably would be. Again, we have a near perfect p-value. There's no chance that these correlations are coincidental. The R, though, is relatively weak, right? So the correlation is weak, and we will see this on the scatter plot. Still, though, this is sufficient enough to test that we rejected the null hypothesis and concluded that there is a correlation between savings and stocks. As I noted before, sort of weak correlation, as we can see here, 0.28, although really no chance that this is a coincidence. We can see here that the p-value is 0, but again, the scatter plot does not indicate a strong positive correlation, perhaps kind of a little bit this way. This one actually did surprise me, because I would assume that most people, as they increase in their wealth, invest more of their savings in stocks. So I was kind of surprised by this particular part of the graph. Perhaps something to test in further research. This was the 9th correlation that we tested. The 9th hypothesis, 0, was that there was no correlation between savings and wallet. Alternative hypothesis was that there is a correlation. Again, another one that showed very strong correlation between what people save and what's in their wallet, which again was kind of surprising. We rejected the null hypothesis and concluded that there was a correlation, and as you'll see on the scatter plot, it was very strong. Here we have this strong positive correlation between savings and what people have in their wallet. Again, you can just look at the line here, very, very strong positive correlation. Not much more to say here, and again, we have this p-value that suggests that this is not coincidental. This was the 10th hypothesis test that we conducted, and another one where we have kind of a weak correlation, but the p-value is not a coincidence. We rejected the null hypothesis based on the data coming from PSPP, but as we look at the scatter plot on the next slide, you'll see that the correlation between stocks and wallet is kind of weak. As you can see here, this is a fairly weak correlation. Again, we have a very small r, 0.19, although little chance that this is a coincidental correlation, as we can see here by the p-value. It's kind of mildly upwardly positively correlated, but not a very significant pattern, something to look at here. People who own stocks don't have highly correlated to the amount of money they have in their wallet, according to PSPP. So the main takeaways from our analysis is that some of the correlations were predictable. For example, the correlation between income and savings, yeah, sure, you make more money, you tend to save more, at least if not in percentage of income, but in absolute numbers. What was surprising was that debt was not correlated to any of the variables, which I was not expecting. I thought that people who had more debt would have, for example, less savings, etc., but that did not really emerge from the data. And what I did not expect, again, is that perfect correlation between income and wallet, and I'm a little bit still suspicious about those results, but those were my main takeaways. This concludes the presentation. If you have any questions, please do not hesitate to ask them. I want to thank you for your time today and look forward to discussing these findings further in the future.